Aha! I see the victim.
Radiant energy, adding a microwave oven transformer to extract the power. Part 3.
Okay, here we are on my lackluster workbench. And I will proceed to extract the beast from this cute little red microwave oven here. No signs of ADHD. Look away. So this right here is all you ever need to get stuff out of a microwave. These screws on the back, not regular, so you're gonna have something that'll open them. They make bits for this, but I got my screws. So having removed the fasty little screws from their position, I've exposed the microwave oven transformer and the capacitor, which you never ever ever want to touch until it's discharged. And you can discharge it by taking a screwdriver, which you are not touching the metal on, and touching the two leads together. That will discharge the capacitor. In this case, it looks like there is no charge stored, which is perfect. Then removing these, which would probably be best done with needle nose pliers. Having those out of the way, what's left is these 4 screws on the bottom here, which usually are the same kind of screws as the safety screws that have the funny little heads on them, like this right here. They're meant to keep people out, I think, or something like that. But anyway, these must be older style. They used regular Phillips, so you can get them out easily. Then you only remove those 4 screws, the transformer comes out, and then 1 screw from the inside, which is this one that's holding the capacitor. I forgot to mention the primary side of the transformer has these wires attached to it. You're going to have something to hook to that in order to retrieve the power from this device. I personally am just going to cut the wires because it's easier, first of all, than removing these, because they have a little button on them that if you do not push, they will not come off. So if you ever try to take these off, you have to push a little button that's in the middle of the connector in order for them to release. But I'm going to need them anyway, and I'm not using this microwave anymore, so I'm cutting the wires. Haha, you are one step closer to finding out if you have been wasting your time watching this video. So, first you want to inspect, make sure that you don't see any kind of burns, like especially around the secondary is usually where that would happen on these. And the wire is still connected at the frame right there. Transformer looks like it's in good shape. I think we have a winner. Let's go hook it up to something and see what happens. Okay, so I got my meter. I'm going to go ahead and test the continuity of the coils. So I have my white and black wires stripped out here so that I can check them out. I'm going to try to do this with one hand. Good luck. So we have good continuity there, and when I check it to the frame, we have no continuity, and you want that to be discontinuous. When you check to the frame on the primary, there should be no continuity. So we have no sound. The primary is good. Let's check the secondary. Now the secondary has all these wires. One of them is a filament wire. It's for energizing the magnetrons, for energizing the magnetron. But what we're going to do is use only, this is going to be the hot wire here, the one coming directly from the coil, and the other one is the one that actually is attached to the frame right here. So we have to disconnect it from the capacitor to check this. So I have one lead attached to the one coming out of the center of the coil in the back, and I go to the frame. Oh no. Maybe it's got some, yes, we have continuity. On this, you're going to see, because it's such a big winding, you're going to see more like an ohm reading than just a noise that says yes, it's good. But you want to be a very high ohm rating on the secondary, and this is a good ohm rating. It should be somewhere between 200 and 300, I would think. So we are looking pretty good so far. I think this is a good transformer. Yes, I'm gonna say yes. Okay, this is the configuration in which I pulled it out of the microwave in. The problem with this is for output, and this is now going to be for input, so we have to change some things here. And the reason is because this is a diode resistor, a high voltage resistor, and it will allow current to go out to ground, but we are not going out to ground, we're going in from ground. So this will have to be turned around, and let me think for a minute. So here's what actually happened with the diode. The ringlet is plugged into where the microwave oven transformer's lead is for one side of the filament. The one with the two wires goes to one side of the capacitor. The one wire filament lead goes to the ringlet of the diode, and the transformer coil lead goes to the other side of the capacitor. Wire with two wires that goes to the filament, and you have one wire that goes to the filament. The one with two wires goes to one side of the capacitor. The single wire filament goes to the ringlet side of the diode. The other side of that diode is going to go to, it goes up to the spinning plate, and it is connected to the frame of the transformer right here. That's this one. So that goes to the spinning plate, and then to the other side of the diode that's attached to the single wire lead to the filament on the transformer. That I just discussed is on the secondary. The primary is just the output voltage, and what I had to do was I hooked the two together, and you use one wire to connect from these two. Is going to be one lead of your output, and the frame of the transformer will be the other lead of your output. And that's how I was getting the 100, right at 100 volts of 3 amps ish. Oh, I'm sorry, this is the first video. I wasn't supposed to tell you that. I'll have to delete that. So anyway, these two, the black and the white, you will tie together, and you will use the frame for your other lead of the primary, which is actually the secondary in this configuration. I know that's confusing. I'll draw schematics.